causing any complete outage. So even people will not wait for the primary website to be up or access. It will give the backup website for user to access it. That's a graceful failure, we can call it in AWS. And here, uh, uh, in a typical IT, yeah, environment, you'll call database, machine learning, or the analytics and search, email, everything. You'll call it as some like servers, right? Like database is a server, machine learning is one of the algorithm that you would be applying on the data, and analytics is one of the feature to understand how we analyze analyze the incoming data to predict something out of the business, right? And email application, everything. So here in the AWS, what you will call all these as a services. These are not servers at all. Okay, the database is as a service, database as a service, machine learning as a service, analytics as a service, email as a service. Everything what you put in the cloud is a service, not a server. Okay, and when you give the database as a service, as we discussed in the earlier slides also, right? You pay for what you use it, so it will be the low cost effective things, right? You would be paying how much ever data, the space that you wanted, you would be paying only for that. But in the traditional IT, if you buy something database with some 100 like TB or 50 TB capacity, you need to pay for that 50 TB. Either you would be using 100 50 TB or not, right? So, but whereas when it comes to the cloud computing, you would be treating them as a service, and you pay for the service whatever you have using in your application. And coming to the databases, you have DynamoDB, Elasticsearch, RDS, Redshift, my MSQLDB or ECLDB. All these databases as a service which is available in the AWS. And all the support capabilities, or hardware availabilities, any kind of a support once you buy these services will be provided by the AWS at any point of time. So there will be a service provided, and if you wanted to scale the services, let's say if you have some 100 TB, you wanted to scale it up, you can do it just by buying additional servers from it, so without even affecting your existing business, which is been already deployed and working perfectly. Okay, and okay, redundancy. So, redundancy in general topic, what you see is, right, like you redundancy of the data, what the RDBMS will take it out, right? So in here also, redundancy removes a single point of failures from systems. So if there this is achieved using multiple resources for the same task in standby or active mode. Let's say I have a task to complete, okay, and this resource is in active mode and this resource is in a standby mode, for example, okay. And if there is any failure happens at the time of the task which is in processing, the another resource in a position which is in standby mode, in a position to take that request and complete the task without any interruption. So it what it does, like it removes a single point of failures from the system, okay. And what is a standby redundancy? This is also one of the feature in the AWS. Like it's used for stateful components like databases. So when you have the database, you will have the standby database, which means you wanted to retrieve some information from the database, like your primary database got scrapped or something or fail over, which is not been accessible at the time of the request being sent to it. Your standby database is in a position to take that request and fulfill the request. This is where we have seen in one of the previous process, if any failure happens, AWS services are in a position to keep the data recovery and keep that particular service available, so that that service can take that future request without any interruption, without any failures. We have already covered this portion, but here we are talking in terms of standby redundancy. That's the only difference. And active redundancy, what active redundancy does here is like when you have a multiple redundant components. Here you have a task here. You wanted to complete this task, but you have one server which got failed, but you have two more standby servers, which will one of them acted as active server in case of one server is getting failover. Um, Either of the server will take that request and process it, but the another server will still be in a standby mode. Like it doesn't it will make sure that it will not have any kind of a loss of request which has been taken by this web server. So the elastic load balancer will be in a position to accommodate the new servers when there is any request. So this is the active redundancy we'll talk at in terms of the transaction wise. And coming to the failure detection, and what I mean, the automatic failure detection um, allows you to react on the outage automatically without the need of the manual intervention. So from the starting onwards, we are discussing about there shouldn't be any kind of a manual intervention if there is any failure happens. How our systems will be, configured in such a way, like your load balancer will be here, and it checks the health check every time, like HTTP 200. It checks the health check for this particular resource. It will periodically send that request to its resource and see if the HTTP 200 is coming as yes, which means this resource is active. It can take the next request and process it. And if the health check is coming as a no for HTTP 200, which is no, which means this resource is not getting the response to the information or the request being sent to that particular resource. That time, this resource will not in a position to resource is not in a position to take any kind of a request, right? So if the request is taken by this particular resource, or else take this example, your request has come to this particular HTTP health check, and this is coming as a no. So it will go for the next one, next balancer which is available, and go to that particular resource. If it is HTTP 200 is yes, and then it will go to the launch new healthy, which is another resource, and move to the resource one. Failure detection. Okay. Okay, I think there is a small correction here. If the HTTP 200 is, it will go to the resource. If HTTP 200 is no, what it does, the elastic load balancer will give new resource. It will launch the new resource, right, and make it active. It doesn't, go to the next one. So failure detection, it detected the failure server or the resource, and it will create a new launch a new healthy resource for the process to be taken. Okay. And coming to the next one, durable data storage. So what the service does is replicating your data to another sites or resources protects its availability and integrity. So the availability of the data and integrity of the data is very much important when we are working in a database, like database environment. Uh, like we have when we wanted to take the replica of the data, we have the three process or the three ways that a replica of the data can be taken. One is asynchronous data, and the other one is synchronous data, and the third one is QRM based. So these three approaches it will follow and take the replica of the data. This is when if the data is failed in one instances, it will be in a position to take the data from the different location and fulfill the data and make the data available for the next transaction. And coming to the synchronous replication, and synchronous replication ensures that the data has been durable stored on both the primary and the replication location, which means uh, whenever you store the data, let's say let's take this example only. You're writing the data, right? Some write operation you're doing. So this is your primary resource to store the data, and this is your replica resource to store the data. In the synchronous replication, it does the same operations in the two different resources. It write the operation here as well as here, and it will write back the acknowledgement from this server and also from this server to the user. So every time all the replicas will be in sync. So the status will be in sync in both the servers. That's a feature, one of the feature in the AWS by the synchronous replication. And asynchronous replication also we can configure, which is asynchronous, which means both are not in a sync, right? So you write some operation here from primary resource, it will go to the replica of the secondary resource, but acknowledge being sent from primary resource to the user. There is no acknowledgement information being stored in the replication resource. This is called the asynchronous replication. And the next one is QRM replication. The QRM based application is a mix of both the synchronous and asynchronous replication. When you're writing some operation, it will go to the primary resource and it will go to the replication resource where you will have the pool of resources available, and it writes in a two servers only, which means not in every server which is there in that pool. It will write in a very few servers, and again it writes back that acknowledgement back to the primary resource and acknowledgement sent to user. So when you wanted to see this acknowledgement in all the servers here, you will not find it, but it will have in a very few servers, which is called as QRM replication. So this is the combination of both the synchronous and asynchronous uh, data copy mechanism. This is how we see that the data will be replicated, right? These are the three replication mechanism. And coming to the data center resilience, you'll have two different data centers, like primary data center and the secondary data center. Let's say if there is any failure happens, or from the primary data center, the secondary data center will be in a position to take that particular request, and it will give that information back to the request which has been requested. And having said that, this primary data center and the secondary data center both are in a sync, so there won't be any data which is been different from these sources. So if primary data center is if any failure happens to this primary data center, secondary data center will be in a position to take that request and provide the data back to the request. And the data center resilience. So here we talked about the availability zone and the region sometime before. What exactly the region, and inside the region you'll have the availability zones, right? So in the data center resilience, what it actually does is that all the data centers are configured to provide multiple availability zones. This is this portion in each region with low latency work network connectivity, which means like when you are replicating your data across data centers in a synchronous manner, and as a result the failover becomes simpler, which means you have the availability zones here. If one data center gets failed, right, like availability zone 1, which is zone A, zone B, and zone C, right? If any particular data center availability zone gets down, so there will be another availability zone to take that data in a synchronous manner, and the result failover becomes very simpler.